So our new chapter is basically going to be about trigonometric functions. So what is trigonometric functions? They're basically, it's the study of triangles. This isn't related to what we have previously done. This is something new, but it's still important for higher level mathematics courses. We need to know this. And then we're going to look at things like sines and cosines. But what we're going to basically be focusing on is measure of radiance, unit circles, degrees, special triangles, and later on doing cosines and sines. There's a joke, math is rad, because we're going to be talking about radiance. Sorry for the joke. So the unit circle. The unit circle is essentially in the study of trigonometry. So the unit circle is basically what we've done this before. This isn't anything new. We have the origin at 0, 0. And so the unit circle with a radius of 1 at the origin is just going to be x minus 0 squared plus y minus 0 squared equals to 1. So this implies x squared plus y squared is equal to 1. And we get this formula, x squared plus y squared equals 1. Nothing new. So let's look at this example. Find the points on the unit circle whose two coordinates are equal. Well, we just found the unit circle was x squared plus y squared is equal to 1. So basically, any point on the unit circle has these coordinates x, y, such that x squared plus y squared is equal to 1. Now the question asks us, find the points on the unit circle whose two coordinates are equal. So since we want the two coordinates to be equal, what does this mean? We need x to equal to y. So then, for such a point, where x equals y, we have essentially x squared plus x squared, because they are equal, is equal to 1, which implies therefore 2x squared equals 1. So therefore, x squared equals a half, which implies our x is equal to plus or minus square root of 1 over 2. And our y is the same because they're equal. So it's plus or minus square root of 1 over 2. Thus, I'll write a little, I'm leaving a space here for a reason. The points on the unit circle where the two coordinates are equal are these points. So the first one would be square root of 1/2, and the other point is square root of 1/2, and the negatives of these. Okay, so we could try my best to draw a circle. Okay, of a unit circle. And just imagine like it's a perfect circle. I know it's not the best for me. As long as it resembles a circle. So this means when x equals y on this unit circle, this point, so with this radius 1, a particular point, we could draw a triangle, sort of, and project this point down onto the axis. You see it's 90 degrees. So this point here, where they're equal, so this would be projecting it as square root of 1/2. This would be square root 1/2. So we have like this particular point, color code it as square root 1/2, square root of 1/2. And this is a 45-degree angle I drew, because they have to be equal on both sides. So this would mean this would also be a 45-degree angle. And this is a 90-degree because they all have to add up. And in a triangle like this. So this is sort of like one of our first triangles that we're looking at. Now, there's positive angles and negative angles. So basically, just think of a clock. If you're going in the clock, you don't begin actually going in that direction, in that clockwise. So positive angles are actually opposite to the direction of the clock. They're counterclockwise. So counterclockwise is how we begin taking our angle from the horizontal positive axis. So this is an axis. We start counting this way around. So it actually refers to the opposite direction from the motion of a clock's hand. So I'm just making sure you know this. So the radius of the unit circle corresponding to like this particular angle in degrees is the radius that that angle has with the positive horizontal axis as measured counterclockwise from the positive horizontal axis. So let's just see these by sketching some pictures here. So sketch the radius of the unit circle corresponding to each of the following angles. So again, try your best to draw a circle. It's not perfect, but we tried. So 15 degrees. So this is the x-axis here. Usually, I won't write it. And we measure the angle counterclockwise to this axis. So let's just write it out. So 15 degrees would be about, let's say here, 15. Like a small, like little sliver. So this is 15. Okay. What about 90? So 90 degrees is about, so the whole circle has 360 degrees. 90 is, there's like 4 slices, 1, 2, 3, 4. 90 is here. So we measure to here. And you can have a box to denote 90 degrees. So this is 90. $135. So this is a little harder. Now we see if the unit circle is 360 degrees, half of that would be 180, about 1 here. But this asks for 135. So that's about here. It's less than 180. So again, we start our position here and go around the circle to 90 and then past it a bit to about here. So this would be 135. And the last one, 210, well, we go again, we start here, we go to 180, but then it's about 30 degrees more than 180. So then we keep going. So go to here, and then a little bit more. This is all about 210, sorry. I'll just label, this is with radius 1, 1. This is -1, -1. So again, the positive direction is counterclockwise, to repeat that. Now, there's also negative angles, which are sometimes useful to consider the radius of the unit circle corresponding to this negative angle. By a negative angle, we just simply mean the angle that is measured counterclockwise is the key word from the positive horizontal axis. So we have like this angle, let's say it's less than 0. In this case, the radius of the unit circle corresponds to this angles and degrees, essentially in the radius that has this angle with the positive horizontal measured, again, counterclockwise. So it just basically refers to the correct direction of the clock's hand as it goes around. It's like clockwise is like a clock. So sketch the radius of the unit circle corresponding to each of the following angles. So again, let's try to sketch. Oops. So suppose that's a unit circle. So -30 degrees, what direction do you think this goes in? Right, so it just goes down here. So you start, of course, this is where you always start, pointing to this axis. And this is all, imagine 1, 1, -1, -1. So -30 would just go downwards. What about -60? So -60 would just be basically, again, downwards another 30 units. So this would be negative 60. And then our last one, green, would be negative 90. So what is negative 90 degrees also equal to? Pardon? 270. Right, 270, perfect. So it's also equal to, you could start going counterclockwise this way, and this is 270 degrees. So 270 is equal to negative 90 degrees. So they're the same thing. Again, these are examples of going in this direction, essentially. So we just observed that the radius of the unit circle may be represented by different angles. So we noticed 90 degrees was equal to negative. So we notice here negative 90 was equal to 270. So what do you think 90 degrees is equal to in terms of negatives? Negative 270 degrees. Or negative 30 degrees, what is that equal to? Right, 330 degrees. And we found negative 90 degrees was equal to 270. So we can go clockwise or counterclockwise, it's just noticing. So angles greater than 360 degrees. Sometimes we consider angles greater than these 360 degrees. Such angles arise by starting at the positive horizontal axis and looping around the circle more than one time. So let's loop at some more examples. Let's continue drawing some circles here. So the same radius of the unit circle corresponding to these values. So let's draw a sketch. It is a bit of a challenge for me to draw a nice circle. Okay. So 45 degrees, as we noticed, is about where x equals, because this quad is 90 degrees, so it's halfway between, like that. So this is 45 degrees. What about 405 degrees? What is this equal to? So it's 360 degrees plus 45 degrees. 360 degrees is one loop. So basically we start here. We could go around once and then we end up here. I hope you saw that. And this is where we have the loop n, let's say, equals 1, because it's one loop. What about 765 degrees? Right, yeah. So it's 360 degrees plus 360 degrees plus the 45. So you have one loop plus another loop, so two loops. So our n here is 2. We're going twice. I'll explain what n is. So we essentially go around twice. So we go around once, go around again, and then go to 45. What about negative 315 degrees? So in this case, because it's negative, you notice we go 45 degrees, subtract 360 degrees equals negative 315. So we go in the opposite direction. And we get negative 315 degrees. So it's sort of like going this direction and then going up again. So again, it's the same value. So this is, let me write a little note, a loop in the negative direction. And what about negative 675? Same idea, going negative twice plus 45. This is when n equals negative 2. So we could go negative twice, 1, 2, and then go up. I won't draw it. This will be a little messy on this diagram. So what did we just learn? Essentially, we can add multiples of 360 degrees to our angle, and we get that same angle. So this example hints at the following result. Multiple choices for the angle correspond to a radius. A radius of the unit circle corresponding to your degrees also corresponds to that angle plus multiples times 360 degrees, where n is basically any integer, positive or negative. So we have like this n here. So moving on, the circumference of a circle with radius r is equal to 2 pi r. I think you guys know that from high school. The circumference of a circle is 2 pi r. Yes? We're going to use that. We'll just circle it. Helps us remember something. So the unit circle has r equals to 1. So that circumference when r equals 1 is just 2 pi because r equals 1. And this corresponds essentially, so 2 pi corresponds to one loop around the circle, which is 360 degrees. So let's say we have, draw this circle again. So one loop around, so a loop, go around the circle is equal to 360 degrees. So 360 degrees is equal, the same thing, when the radius is equal to 1 as 2 pi. So 180 degrees, half of this circle, corresponds to 2 pi divided by 2, which is therefore just pi. So half of the circle is pi. So it's actually kind of important. So then an arc corresponding to 180 degrees, we can draw this. So half of the circle So this is 180, because the whole thing has the circumference of 2 pi divided by 2. So I'll just make a little note. So 360 degrees is equal to 2 pi, because this is the circumference of a circle. This is all you really have to remember, is 360 degrees is equal to 2 pi. So this means 180 degrees is equal to pi, which is basically half of the circumference of the circle. So this means the length of the arc. I'll explain this, formed by the circle, formed by 180 degrees on the unit circle. Okay, let's just see another example before we. So 90-degree angle is about this picture, as we can see. And this is equal to pi divided by 2. How can we see that? So 90 degrees is equal to pi divided by 2. And this is equal to the length of the arc formed by 90 degrees. 90-degree angle on the unit circle. And this is the case where r is equal to 1. Our angle here is 90. So this is our arc length. Which is equal to 2 pi times our radius, which is 1, times our, and how we converted it was 90 divided by 360 degrees, because that is the fraction. And this is equal to 2 pi divided by 4, which is just our pi divided by 2. So I hope you can kind of see that. Because we're just taking it from degrees into our pi's when r is equal to 1. We're just making that transformation from degrees to things with pi's in them. Now, there's a formula for this. So you observe that this length of the circular arc is actually with a corresponding degrees on a unit circle with this radius, has this length 2 pi r times the degrees divided by 360 degrees. And if r equals 1, it's just 2 pi times that angle divided by 360 degrees. So this is useful when keeping in mind, so keep this in mind, this formula, when 2 pi r corresponds to 360 degrees. It just basically means like 360 degrees is equal to 2 pi r, which is equal to 1 revolution. We'll repeat this in the seminar. So let's look at special triangles. The 45-degree, 45, and 90-degree triangle. So before we showed that the radius of the unit circle has its endpoints at square root of 2 divided by 2. we said actually before it was equal to the square root of 1/2, square root of 1/2. And you can show that this is equal to this by just manipulating it and multiplying it together. I'll leave that as an exercise. Now, let's look at this example and draw a circle. So this means at 45-degree angle, this means this is also 45 degrees, and this is 90, because the whole interior of an angle, the angles have to add up to 180 degrees. So this point here is the square root of 2 divided by 2. This is the square root of 2 divided by 2. This is, of course, our 90. And then we have our points. This is square root of 2 divided by 2. And this point, if you project it, square root of 2 divided by 2. So that is one particular triangle. And we could summarize it here. Draw it. So this length, square root of 2 divided by 2, square root of 2 divided by 2. This has radius 1. In these angles, this is 45. This is 45. And this is, of course, 90. I'm just rewriting the triangle from the unit circle and drawing a triangle. So that's one special triangle. What about 30, 60, and 90-degree triangle? So let's again draw that unit circle. Again, try my best. It just has to resemble a circle. Doesn't have to be perfect. Okay. So we can draw 30 degrees. This is, let's say, our 30 degrees. And project this value down with a straight line. So this becomes 90. So if this is 30 and this is 90, what angle is this? Let me redraw it a little nicer, actually. I'm just redrawing it like a little larger. So this is 90. So this would be 60, because the whole interior of the angle has to be 180. Now, if this particular, when this happens, this is a half this distance. Now we could solve and we could find out that this distance here, this point, is square root of 3 divided by 2. So this particular point here is going to be square root of 3 divided by 2 and a half for our y point. It's a bit, we could use Pythagorean Theorem to find out that point. Pythagorean Theorem, which is this a squared plus b squared equals c squared. Suppose we had our y point was a half. Well, a half squared is 1/4. So this is 1, our C is 1, so 1 squared, 1 minus 1 over 4 is 3 over 4. And then take that square root of 3 over 4. So the square root of 3 divided by the 4. So the 4 becomes a 2. So this is how we could get that other side if we wished. It's a little bit of just rearranging the formula essentially. But let me just redraw the triangle for you. So this is your 30-degree angle. This is your 60-degree angle. This side is a half. Let's call it B if we wish. This side is the square root of 3 divided by 2, which is A, and C is equal to 1. And how you kind of can remember it is across from 30 is that side is a half, and across from 60 degrees, that side is the square root of 3 divided by 2. So that's how you remember. Just remember one of it. 30 degrees across from it is a half. And then you can kind of figure out using the theorem the other sides. That's how I memorize it. Now, radiance. So remember that one loop around a circle corresponds to a 360-degree angle going once around the circle. Instead of using a rather arbitrary number such as 360 degrees, we can refer to an angle corresponding to one loop around the circle with 2 pi, the circumference of this unit circle. So this idea is captured in this notion called radiance. So the definition is written down here. So radians are a unit of measurement for angles that correspond to 2 pi, radians. So 2 pi radians corresponds to 360 degrees. So save your brain power and just remember this definition. And you can like derive everything from this. So 2 pi rad. And I'll explain what radians are a little bit. It's just like the arc of the arc length essentially of this. So 2 pi radians corresponds to 360 degrees. You could divide both sides by 2 pi, and then you would know what 1 radian would equal. So it would be 360 degrees divided by 2 pi would be 1 radian. But let's first see how to convert between radians and degrees. So let's convert each of the following angles from radians to degrees. Let's do this together. So we know 2 pi radians, let's say rads, is equal to 360 degrees. So then therefore, pi rads is just going to be 360 degrees divided by 2. So this would be 180 degrees. So therefore, pi radians is equal to 180 degrees. So I'll just write it up here, what to remember. So 2 pi radians or rads is equal to 360 degrees, which is just 1 revolution, 1 loop around the circle. They're tomato. It's like I say, hello, bonjour, hola. It all means hello in different languages. And we're just converting from one to the next and then back and forth. So it's the same thing. And once you know how to convert, you can convert anything, kilometers. It applies to physics as well. So it's actually a very useful technique. What about pi over 2 radians? Could do 2 pi. I'll just not write the radians for now. 360 degrees, divide by 4. So I'm just dividing by 4 on both sides. Get pi over 2 equals 90 degrees. So therefore, pi over 2 radians equals 90 degrees. What about 3 pi over 2? Well, we know 2 pi is equal to 360 degrees. Could divide by 2. This means pi equals 180 degrees. Then we can multiply by 3 over 2. So then this gives us 3 over 2 pi is equal to 3 over 2 times 180 degrees, which is 270 degrees. So therefore, 3 pi over 2 radians is equal to 270 degrees. But if you remember this up here, it'll really help you. Now let's convert each of the following angles now to radians. So we're going the other opposite direction. So we know 2 pi is equal to 360 degrees. Could divide by 360 degrees. A little bit more. So 2 pi divided by 360 is 1 degree. And then we can multiply it by 30. So it gets a little messy here. So 30 times 2 pi divided by 360. So 30 times 30 is 60. 60 divided by, goes into 360 6 times. I'll cancel that. So this implies 30 degrees equals pi divided by 6 radians. The next one, 45. So this is 2 pi equals to 360 degrees. Divide by 360. So 2 pi divided by 360 equals 1 degree. Times it by 45, both the left and the right hand side. So 45 times 2 times pi divided by 360 degrees equals our 45. 45 times 2, that's 90. 90 going into 360, that's 4. So this gives us 4. So 45 degrees equals pi divided by 4 radians. I'll leave this 60 for you as an exercise for you to complete. Now, I just worked at like using the definition and using logic essentially. I try not to remember too much. But there are formulas for you. So converting radians to degrees or degrees to radians. So we can just take 180 times our radiant measure divided by pi, and that will give us our degrees. Or we can convert the degrees to radians. If we have the degree, multiply it by pi, divide by 180, and then we have a radiant measure. So that's what we just did, but there are formulas if you felt like memorizing those formulas. Let's just see 2 examples and we'll take a quick break. If you remember that 2 pi radians corresponds to 360 degrees, you don't have to memorize the formulas. It's kind of easier. Again, I'll help you, I think, in the seminars. So let's convert 49 pi divided by 90 radians to degrees. So 49 pi divided by 90. So we're going to apply the formula. So we're going to take 180, plug this into this formula. So this is 180 times this angle, this radian, divided by pi. This is going to be in degrees. So this would be 180 times 49 pi, divide by 90, divide by this pi. So the pi's cancel. And you got 90 going into 180. So I'll rewrite it twice. So the 180, I'm just rewriting it, sorry. So like these pi's cancel. The 90 goes into 180 twice, so there's a 2. And then 2 times 49 is 98 degrees. I'm not sure if this is easier. And then converting degrees to radians, applying the formula. So this is 23 degrees. So applying this formula, take the 23 times pi divided by 180. And this would be in radians. So this, you can't really simplify it. So 23 pi divided by 180 radians. So you just like leave it alone.